We are told to state the principle of transmissibility of forces. For us to say this principle of transmissibility of forces, okay, this is how to state it. Okay. Answer. Principle of transmissibility of forces states that when a force acts upon a body, it affects its effect, not affect, its effect is the same. Its effect is the same, comma, whatever point in its line of action is taken as the point of the application, provided that the point is connected with the rest of the body in the same invariable manner. This is just the law. That is, when there is force, force acting upon a body, the effect of that force are the same. Whatever point in its line of action is taken as the point of the application, provided that the point is connected with the rest of the body in the same direction. That point will be connected with the rest of the body in the same invariable manner. They will be connected in the same invariable manner. That is, they will be in the same line. Even if I were to I'm like to explain it more, it's like saying that the connection, if we have like 3 connection, they will move with the same force. That is what the principle of transmissibility. That is, okay, Tolulope will move as Michael, Tolulope, Emmanuel, as they are moving with the same force. That is what principle of transmissibility. That is, the same force will be transmitted through them. That is, maybe the force is force P, it's the same force that will be transmitted through them. Also, when we look at the question 2, we were told to explain briefly resultant force and component of a force. What is a resultant force? Resultant force, the definition of resultant force. This is a single force. Which can replace 2 or more forces and produced, and it will definitely produce and produced the same effect on the body as the force and we are also told to define the component of forces. Component of forces is also known as component of a force. Another name for it is called, this is known as resolute. It's known as what? As resolute. And and the part and this component of force, this is a part in the resolved in the resolved force. It's just a part in the resolved force. That's just the definition. Okay. Looking at this now, they say if the resultant of two forces P and Q is given as we were to so what will the resultant become if theta equals to 0? If your theta, okay, solution. No, even in 3 dimension, if you are also given, if your theta is 180, I will give you the 3 formula. If theta equals to 0, that is saying the forces P and Q act along the same straight line, then your R will be equals to what? P plus what? Q. But if theta equals to 90 degree, your R will be square root of P square plus Q square, and your what? For if theta equals to 180 degree, your R will be equals to P minus what? Q. If theta, although you are not given this one, but if your theta peradventure is 180 degree, your R will be what? P minus what? Q. Okay, let's talk about question 4C now. Question 4C. The question 4C was saying that use the Cartesian vector notation method to determine the magnitude and determine the direction of the resultant force system shown below. Draw the vector diagram for resultant forces. Okay, if we are to use the Cartesian vector notation method to determine magnitude and determine the direction of the resultant forces, okay, this is what we are to do. Okay, we have 3 forces. These are 3 forces, and we have what we call horizontal component and what? Vertical component. Okay, for you to solve this now, you make use of Cartesian vector notation method, and that's let's first deal with horizontal component. To deal with horizontal component, that's summation of horizontal. You see, you look for your starting point. This is my starting point, and this place is 0, and this place is 0. That means my f of 3, which is 7, it will be 90 plus 45, and that will be 750 cos 135 plus, and it will move again from here to this guy here. That will be 180 plus 90, that's 270. I will have 625 cos 270 I have cos 270 here. Okay, if this one cos this one, there is 45 degree here because it's bisecting it at the middle, plus 850 cos what? Cos 270 plus 45, and that will be, I think that will be 315. I will press my calculator to get my answer for that. Also for a vertical component, it will be 750 sine 135 plus 625 sine 270 plus 850 sine 315. Okay, when I get my answer, when I press my calculator, my R will be square root of summation h square plus summation v square. Okay, and I can, from here I can also get my direction. My direction will be equals to, my direction, that will be theta or alpha, anyone I name it, alpha tan inverse of summation v over summation h. That will be my answer for it. And if I press my calculator to get it, this is what I have. When I press my calculator, this is what I get for my resultant. But for me to now get my, this is what I get for my resultant when I press my calculator. But for me to get my direction now, I will put my summation of vertical, that's 695 minus 695.771 over 70.7. When I press calculator for that, I'm going to have 695.711 divided by 70.71. I'll definitely have tan inverse of minus 9.8389. Okay, equals to times minus 1. Okay, this is what I have. I will now find the tan inverse of it. When I find the tan inverse of this, tan inverse, that will give me minus 84.196 degree. This is my answer. But they say I should draw the vector diagram for resultant forces. This is how the vector diagram will look like. Our vertical, I mean our summation v is here, which we get to be what? To be minus 695.771, and here will be our horizontal. This one will stand for our summation h, and that's 70.71, and here is our resultant, which is 69295 Newton. Okay, this is my answer for this one. It the thing would definitely bend, because this our vertical is negative. You can withdraw it like this, because it will be downward like this. It can look like this. This is how it will look like, because there is negative here. This is our summation v, and this is our summation H, and this is our R, because it is in negative form. That's why it will bend, and that's our answer.